So you will present both paper.
Yes, sir.
So just go with the 61699 and then 4352.
Okay, sir. So, firstly, that lambda NF problem paper.
Yeah.
Yeah, okay, sir. Yes. Sir, is the screen visible?
Yeah, visible.
Okay, sir. So, good afternoon, everyone. I am Anurag Dutta. I'm going to present the paper, the lambda NF problem, at the conference ICCEDE. So, currently, I am an undergraduate at the Department of Computer Science and Engineering at Government College of Engineering and Textile Technology, Shirampur. So, let me begin with the paper presentation. So, firstly, I would be talking about the introduction. So, actually, this paper is something about the Dutch national flag problem. So, I have just extended that Dutch national flag problem to something which could be applied to a flag which will be having like lambda colors. So, as we know, the Dutch national flag problem is a computational problem relating to the flag of Netherlands, which have three colors inside it: red, white, and blue. So the problem statement is such as, like, given will be an unordered set or unordered list, and we have to select a permutation of that particular list, which is to be found such that the ith value of that particular list would be less than or equal to the jth value of that particular list, such that that particular value j would be greater than that of I. Now, the list would be filled by only three values for the Dutch national flag problem, and which would be beta, gamma, and delta. Now, it would be the same for all, like I greater than equals 0. And it is mentioned that the three values beta, gamma, and delta won't be equal to each other in any sense. Now, this is the Dutch national flag, and the naive solution for like finding that particular permutation would be like we could apply some of the sorting algorithm, like that merge sort or heap sort or anything like that, and we could just sort them. Now, if we do that kind of approach, then the computational time complexity would be of the order n log n, and the space time complexity would be of the order n. Now, we could definitely do something better than this, which would be done by making use of the hashing concept. So, we could just traverse the whole list and store the count of beta, gamma, and delta. Following that, we could just strive out the whole list for establishing comparison between these three values on the basis of their magnitude. And in this case, we would be getting the computational time of the algorithm as of the order of n, and the computational space time would be of the order of n2. So it is quite better than the previous algorithm. Now, we can still do something better, which is by the Dijkstra solution. Now, Dijkstra proposed this kind of solution that we will have to indulge one invariance, that is the low would be less than equal to mid, and which would be less than equals to high. Now, low, high, and mid will be three pointers which will be pointing to 0, 0, and n minus 1, where n is the cardinality of the set we will be dealing with. Now, we will be pointing these three to their respective positions, and if the value of the mid, like the list's mid element, is equal to minimum of this beta, gamma, and delta, we will perform in place swaps with the lowest value and the mid value, and with that we will be incrementing the low and mid. In the other case, if we are having the mid value as being equal to sum of all of this minus minimum of all of this and maximum, this is basically the second most largest value between beta, gamma, and delta. It is a generally a generic way of representing this. And in the third case, we would represent it as the maximum of these three values. Now, for the third case, we would swap this highest value and the mid value, and will be decrementing the particular value of high. Now, according to that, we would have proposed a new problem, that is the Indian national flag problem. Now, all of us know that the Indian national flag is having like four colors, one that's saffron, then white, then green, and navy blue. So, this is quite similar to the Dutch national flag problem, but the only case hereby is for the Indian national flag problem, we would be having four particular values: beta, gamma, delta, and epsilon. Now, again, the particular values won't be same. Now, we could make use of the Dijkstra solution for solving this Indian national flag problem, and we would get something in linear time probably. And by making use of this same approach of Dijkstra, we could extrapolate our work to a new problem, that is the Zimbabwean national flag problem. Now, Zimbabwe national flag is having five colors. Firstly, green, then gold, then red, then black, and finally white. So again, we could apply the same concept thereby and would get that correspondence as same. Now, extending further, we got the main problem, that is the main work of our paper, that is the national flag with lambda colors. Now, if we are having a national flag having lambda distinct colors C1, C2, C3, that would go up to C lambda, then we could describe the problem statement as we would be given an unordered list. Ln would be equals to alpha 0, alpha 1, alpha 2 up to alpha n minus 1. A permutation of that particular list is to be found such that they would be in sorted order, and alpha I would be equal to C1, C2, C3, or C lambda. It could be anything amongst that. And again, the particular values can't be same. Now, here the C1, C2, C3 up to C lambda could be considered as a correspondence to the colors of the national flag. The problem can be solved via in-place swaps like we mentioned previously. The algorithm targeting to this problem can be sort of quite easily, but at the computational cost is would be of the order, it is like floor of lambda by 2 times n, though it could be done with no additional space. Like for the solution with hashing, we would have to make use of additional space of n, but in this case we don't have to make use of such kind of additional space. Now, the worst case at the worst case, the lambda nf problem can be accounted to lambda as being equals to n, and all the elements of the list being different. The best case, the lambda problem can be accounted intuitively. Now, to conclude, the lambda NF problem could be sort uh, of as a sorting problem in which we would be given a list of numbers with lambda distinct entries. It has been shown inductively in the work that the minimal time the lambda sort can account is totally dependent on the value of lambda. If all the entries are distinct, it would be taking a time complexity of n square upon 2. Now, we have made a claim in this paper that the computational time complexity of the lambda NF problem is going to be floor of lambda upon 2 times n, where lambda would be some value between 0 and n. Now, the proof behind our claim have been mentioned from this slide. Let we have discussed a proposition P lambda as the computational time complexity of the lambda NF problem. Now, since this is something new in this field, so we can't give like a solid concrete proof, but we can do that inductively until and unless no one finds our solution as wrong, our solution would be like right. So it's kind of hypothesis. So the base case is like the lambda being equals to 1, and as we know that the floor of 1 upon 2 is 0, which seem to fit completely. As in the list which is having a single variety of entry, sorting is irrelevant. Like we can't sort a list having only one element. So this seems quite fit. Now, the induction hereby could be like let us consider that every instances of the proposition p1, p2 up to pn minus 1 is true. Let us assume that. So, by making use of the strong induction, we could say that we need to conclude that pn is true. The proposition pn states that all the entries in the list ln are distinct. In the work, like it is one of my previous work, I have like presented this work in one of the IEEE conference, that we have tried to think sorting in terms of searching. So this was one of my previous work. In that work, I mentioned that Pn, like the proposition which I have talked in the previous slide, it would be equal to n plus n minus 1 plus n minus 2. It is basically the summation of the numbers, natural numbers till n. It is quite understandable from the proposition that it would be of the order n square upon 2. Hence, we could conclude that the computational complexity of the lambda NF problem would be lambda upon 2, which will be taken as a floor multiplied by. Now, these are some of the references which I have made use of for preparing my manuscript. So, thank you. This was all from my side for this paper.
Hello, Anurag.
Hello, sir.
Yeah.
Yeah, it is really nice work.
Thank you,
So,
sir.
what I would
Hello,
suggest,
ma'am.
you please extend the work. What is the thing? This lambda and a problem
Mhm.
you are specifying for the flag or something. So,
Mhm.
better to add some further some mathematical modeling and come with the some good SCI papers because this work can be extended.
Sir, I just want to mention that for the presentation, it was like limited to 7 to 10 slides. So I have like reduced 50 to 60% of the information. So it is like looking little
Okay, good luck.
like those algorithms I have mentioned in this paper. The algorithms behind this.
Anurag, I also agree with the Deepak sir. And my another suggestion is apply such type of algorithm in any real-time applications. Then you will go for the good SCI paper.
Okay, ma'am. Okay, ma'am. Sure.
Apply such type of algorithm in any real-time problem. Then you will definitely you go for the SCI paper. That is
Okay,
my
ma'am.
suggestion.
Okay, ma'am.
That's all from my side.
Thank you, ma'am. Thank you, sir.
Okay, Anurag, this nice work. And since you have given the two papers, so
Hmm.
it's a turn for the second paper. And
Okay, sir.
I would just like to, you are the main author for these two papers?
Yes, yes, sir.
Okay. So you can proceed for the 4352 paper ID.
The Indian search algorithm.
Yeah.
Right, sir. Sir, is the screen visible?
Yeah, visible.
So, hello everyone. I am Anurag Dutta. I am currently an undergraduate at the Department of Computer Science and Engineering at the Government College of Engineering and Textile Technology, Shirampur. Today, I am going to present the paper, The Indian Search Algorithm, at the ICCEDE 2022 conference. So, firstly, I would like to thank the organizers of the conference and GL Bajaj Institute of Technology and Management for hosting this conference. So,
Anurag,
le-
you can turn the camera on.
yes,
If
sir.
you don't have any bandwidth problem, then you can turn your camera
Yes,
on.
sir.
That
I
will.
am having some bandwidth issue. Like, it is, it would be going down. Like the presentation would be lagging.
Okay. 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 Proceed.
Okay, thank you, sir. So, let me begin with the introduction. Uh, for searching an ordered list, there exist numerous techniques. One of them being the binary search, which improvises its search and decreases the search space by slicing it in halves and is repeated until the target is hit. Now, in this work, we have developed a new technique of algorithm built upon this divide and conquer technique. But one major aspect behind this paper is this algorithm is going to be our own indigenous algorithm from India. Like there have been little contribution in this searching algorithm kind of field from India. So I think that should be contribution would be great. So the algorithm describes this set of partitions as a term of the recursively enumerable series, especially with the series holding a metallic ratio between consecutive terms for series with high cardinality like Fibonacci series, Lucas series, Bell series, etc. Next, it would be performing a check on either side of the partitions And finally, the partition with the key being possibly encapsulated within the selected and is further searched through by making use of binary search in that particular partition range. Now, firstly, the algorithm. So, the Indian search algorithm is not about a particular algorithm. It is basically a set of many algorithms. Like there could be many modifications in that algorithm. So, first algorithm or the first sub algorithm in that set is the Indo-Palian search. So, the pale series are the ones which follow the rule un being equals to 0 if n is equals to 0 and un being equals to 1 if n is 1, and in the otherwise cases it would be 2 times un minus 1 plus un minus 2. A few term of the pale series are u equals 1 2 0 1 2 5 12 29. It goes on like this. So the closed form of this series could be represented as un being equal to this particular series, which would be which would be non-terminating. It would go up to infinite, raised to the power of n minus conjugate of this particular term upon this particular value. Now this is having this particular proof which I have mentioned in this particular paper. uh, like let we have the list ln being equal to alpha 0 alpha 1 alpha 2 and it is going up to alpha n minus 1, and we are declaring one more sequence being u0 u1 u2, it going up to infinite. Now we will have to choose such a value of I such that ui being less than or equal to n minus 1, considering, now if we consider n as very high like n being tending to infinite, we could propose. Now the proof behind this proposition have been mentioned in the paper, but due to limited time frame of the conference we can't like express that. But considering n being tending to infinite, I would be less than or equal to 1.18 times log base this particular series of telescopes, like n minus 1. Now we could spawn all values of uk for all k greater than equals to 0 and k less than equals to I. This set of uk would be the set of partitions. Now if we consider these I plus 1 values as the pivots and start narrowing down our search space, finally we would reach out to an interval where the key k is supposed to be found. Let that interval be u eta and u eta plus 1. Now we would perform binary search in that particular interval. Now let us consider, for the sake of like proposition, let us consider that the difference between this range is going to tend till n. Now, the worst case time complexity of this particular searching technique would be this great value, this majestically looking value. But we have tried to delineate that, and it would be like Tn would be less than or equal to log 2 root 2 multiplied log n minus 1 upon log square this particular value plus log base 2 of n. Now, we could see that it is going to act much better than the linear search that we have with us. It is quite going to like act much better. The second sub algorithm being is the Indo Fibonaccian search. The Fibonacci series are the ones which is like 0 for n being equals to 0 and 1 for n equals 1, and in the otherwise cases it would be un minus 1 plus un minus 2. A few term of the Fibonacci series would be 0 1 1 2 3 5 8 13 21, like this. The closed form of the Fibonacci series is this particular value. And now let we have that particular, again the same kind of scenario. And in this case, if we consider n being equal, being tending to infinite, we could say that I um, would be less than or equal to 1.16 times this particular logarithmic value. And if we spawn all the values of uk, then this would be the set of partitions like the previous Indo-Palian search. And now we could consider these I plus 1 values as the pivots and start narrowing down our search space. Finally, we could reach out to an interval where the key k is to be searched and found. And again, performing that binary search in that particular range, we could get the searching technique, and the worst case time complexity for the searching technique could be like this. And it we have tried to delineate that, and it would be log root 5 times log n minus 1 upon this logarithmic value added with log n. Now, As a conclusion, we would try to conclude the Indian search algorithm is quite an edge over the traditional naive linear search. Like we can see that this particular graph, that the state graph, is the linear search, and the in the Fibonaccian search and the in the Palian search are quite less. It will be taking quite very much less time. It could be quite seen from the figure. Now, it could be mathematically concluded that in a recursively enumerable series with existence of metallic ratio k plus 1 upon k plus, it would be like this metallic ratio for all k greater than equals to 1 uh, between terms is consecutive, and will be having the computational complexity of the order lambda plus log n, where the value of lambda would be this particular value. Now again, the proof behind this value have been mentioned quite well in this paper. Like I have tried my best to prove that, but that is quite like tedious proof. So though it could be verified that for k being greater, like tending to infinite, the tn would be tending slightly till log base 2 of n. Now, the future works could be encompassed around showing the practical time that this algorithms demands, and if possible, we could try to propose a constant lambda such that that lambda would be the ratio of maximum of these two particular time, that is the practical time and the theoretical time, upon the minimum of these particular two values. Possible reasons for the inflation could be briefly discussed. Also, this search could be used as an intermediate bridge for the Indian sorting algorithm, which is believed to be much more efficient than the quadratic sorting algorithm. These are some of the references which I took help from for preparing the manuscript. Thank you. Have a nice day.
Any query, sir?
Anurag, the model which you shared, na, this all
Hmm.
algorithm, all mathematical modeling is the existing modeling, na. So what is your contribution here? What you are
Sir,
proposing?
this is not like existing. This have been proposed by me. This particular value, or the like HK's value of this particular sorting algorithm, have been proposed by me.
Okay, so this mathematical modeling you have proposed.
Yes, sir.
You are proposing this thing.
Yes, sir.
Okay.
So, continuation with Deepak sir, what is the base of proposing these all mathematical model, Anurag?
Sir, ma'am, we have tried to like break down the search space into partitions, and based on that, the partition that we are like suspecting that our key is about to be found there, we would be running one binary search on that partition only, and based
So,
on that,
your algorithm is look like a partial fractions. That
yes,
means
ma'am.
partially it will be search you utilize.
Yes, ma'am, it will be taking help of the metallic ratios that exist between um, like numbers, and based on that it would be breaking down the search space, and on that they will be like searching that.
So where you have proved that your algorithm is
uh,
better.
Sir, it have been proved in this slide. Let me open that slide once again.
Yeah, you have shown some graph.
Yes, sir. Yes, sir. That
What
I
is the
have.
basis for that? What is the basis for that?
Like, sir, the naive algorithm for searching is the linear search. So that linear search is definitely going to take like O of n time complexity, but our algorithm is taking much lesser time than the linear search.
And what about the other searching algorithm? Why you haven't compared with the others one?
Like
Only
the
you
other
have compared
search.
only with the
Mhm.
linear search.
Yes, sir. The linear search is a naive technique, but if we are making use of the binary search as a contrast, it is
Hmm.
quite mm, like similar. It is quite similar, but in comparison with the naive searching technique, it is going to be acting
So
good.
you as you know that you are working on the algorithm, so you must be aware about that the binary search algorithm is better than the linear search, and you have compared with your algorithm with the linear search instead of the binary search or some more advanced search. So why you have compared with the linear search?
Sir, because if we are comparing with the binary search, our algorithm is still performing better, but the difference between that is not quite well visible. Like, it would be showing the deviation for like very big values of n. So plotting that in little graph is quite difficult.
No,
So
we have done some efforts in between, not the better one, so that we can say that the Indian search algorithm is better than the all other algorithms. We cannot say like this. Yeah.
yes, sir. Like, it could be further extrapolated for that Indian sorting algorithm, and I, with my guide, is working on that. So probably we will find something better.
Yeah, yeah. You can go for the better comparison with the your algorithm with the better comparison search algorithm. That would be more valuable,
Right,
right?
sir. Right, sir.
Thank you, Anurag, for
Thank
joining.
you, sir.
Now you can leave the session.
Okay, sir. Thank you, sir. Thank you, everyone.
Thank you.